adjust my camera really fast. Just to say hi. Hello, everyone. I presented a couple months, maybe 3 months ago now, also at this meetup. And I'd like to, I've been attending as well, and would just like to start getting more ingrained in the local AWS community here in Denver. So thank you for having me again, David. Thank you for organizing. Thank you, everyone, for attending. Does everyone see the serverless logging presentation here?
Yes, we do. I do.
Okay. And David, you are recording?
I am.
Okay. All right. Well, we're here to talk about logging and the ways to get deep visibility with logging, and specifically how to do that with distributed microservices. And it's something that's been very salient for us here at Big Compass, and it's something that we've been talking about because I believe that normal logging best practices and pitfalls are only amplified when you talk about serverless microservices. So, in the AWS cloud, that's Lambdas. And I think you have to put extra effort into logging. And so it becomes a subject that can be very prevalent for me, for our internal projects, and for our external projects. And I'll introduce myself here in just a second. But we are here to talk about the importance of logging. So I'll just stage up logging a little bit, logging common pitfalls and best practices. And then I want to compare side by side traditional logging, what I'm calling traditional logging, which might be from something like a monolithic application versus a serverless implementations logging. And then we'll just dive into serverless logging and go through a demo of that. And my friend here, Jerry, will help me go through that demo. So just to introduce myself, I'm the cloud practice manager and architect here at Big Compass. You heard a few people on the call here from Big Compass. I'm also from Big Compass. And I have an integration background. I started out with web methods, software AG web methods, and used MuleSoft more recently, and more recently used AWS. And we're kind of using all these tools to put a focus on integrations. And that's exactly where I'm coming from now. I'm AWS certified solution architect and developer, and been digging into the serverless cloud as well as non-serverless as well for about the past, it's been 4.5 years or so in AWS. And Big Compass, from the company that I'm working for, is a consulting firm, and we specialize in integrations and related technologies. And so everyone here sort of puts an integration focus on the work that we do, and we really specialize, in connecting these systems for our clients. And we're AWS partners, so we've been working with AWS, and we work with other technologies as well. For example, MuleSoft and web methods, as I already mentioned, and Dell Boomi. And it's kind of these technologies that play in that integration space. And we like to span these technologies so we can deliver an unbiased solution for our clients. And we focus on building connections. We build connections between systems and applications. That's the integration side of things, of course. But more importantly, we also build connections between people and ideas. And we have this idea that integration can be delivered as a competitive advantage. And I don't think many people think of integration as a competitive advantage these days, or at least yet. But we believe that integration is done right, and along the way, connecting people and ideas really delivers a competitive advantage. And especially in these times where we're socially distanced from each other, I think connecting people and ideas is even more important than ever. So that's me, that's us. Feel free to reach out on LinkedIn or email me at aaron@bigcompass.com if you want to talk more. So let's talk about logging and the importance of logging. And I sprinkled in a couple of quiz questions this time. I'm actually gonna go video off here, so I'm not obstructing anyone's view. I sprinkled in a couple of quiz questions, and maybe we just come off mute, pretty small group, or put in the chat. Either way, what is the difference between traceability and visibility? I'm curious if people are up on your logging lingo. I'll give everyone a second, or like I said, just come off mute and shout it out. Let me pull up the chat here. Anyone? No one in the chat? Jerry, I know, knows the answer to this question, but he's not allowed to answer.
So does visibility has something to do with being able to see something, and traceability has something to do with being able to, I don't know, link multiple things maybe?
Exactly. I would 100% agree. I would also add that I like to think of it as traceability relies on visibility. And I'm going to talk about these two abilities throughout this conversation. So traceability relies on visibility because traceability is the ability to trace, one request or one transaction from end to end throughout its steps. Maybe it takes steps A, B, and C, and you need to be able to tell exactly what those steps were in its life cycle. Visibility simply gives you the access to see what occurred in a system, right? So traceability builds on top of visibility. All right, and we're going to talk about those abilities here on this slide. So why is logging so important? And it's really important for a variety of reasons. I like to pose the question to some clients when we talk about logging designs, and they might push back on logging designs and why they might take a little bit of time. Well, I like to ask the question, can you imagine your system without logging? And think about that for a second. It actually occurred to me as I was creating this presentation is, why is logging so important? If you really think about the antithesis of logging, which is absence of logging, you kind of start to realize the importance of logging. A system without logging would be nearly impossible to debug and to support, etc. It would be a very short-sighted system, or a short-sighted application, short-sighted approach, I'll say. And so I like to think of logging as giving you three pillars of the ilities. And the first ility is visibility, like we just talked about. And visibility, in my opinion, is the backbone to any system. You need to be able to see what's going on in your system to be able to effectively support it. And you need that visibility in your system to tell what's happening at any given moment. So logging the right amount of information to make the system visible to the user is absolutely critical in supporting the system. And then the next ility is traceability. Traceability builds on visibility, as I just said, and traceability allows you to trace one transaction or request from end to end throughout its life cycle. And across distributed microservices, that now is starting to become a more non-trivial task, which we'll talk about more later. And traceability really relies on visibility to give you the right amount of logging, but traceability adds more. So it might add a request identifier that gets logged across different applications, because almost always in a microservices approach, using AWS Lambda, you're going to have more than one, right? It's not just a single microservice. You're probably going to have more than one. And it also allows you to be able to easily put a unique ID and come up with all logs for that request. And so if you think about this from a supports perspective, what I mean by that is if you put in a request identifier to something like, let's just say Splunk, you may be familiar with Splunk, you're going to want to see all of the steps of that particular transaction come up on the screen as a support user. So you can think about that as traceability. And then, of course, those two kind of lead up to the third ility, which is supportability. Supportability obviously relies on proper visibility and traceability, and I just can't stress supportability enough. I've come into systems that are not supportable and done major overhauls just to make the system supportable. And one of the major overhauls you can do, right, is enhancing visibility and traceability to make a system more supportable. And I've also come into systems where support is the number one cost of that system. If you can think about that on an ongoing basis, spending hundreds of thousands of dollars to be able to support a system, when many times it can be automated, or with the right logging approach, at least it can be very, very quick. And then finally, logging is so important because you want to be able to debug. When something breaks, when something goes wrong, which it always does, and we're probably all familiar with that here, you need to rely on good debugging and that good logging to be able to, again, support your system. So let's dive into the logging pitfalls and best practices. And this is sort of generic. It's not going to be specific to serverless quite yet, but just common pitfalls. Number one is no design for logging. And you get kind of the dark background here, right? Because this would be sort of the evil side of things. The no design for logging. And I think there's two key items in implementation that oftentimes go forgotten. Number one is API security. And the other we're here to talk about today is logging. You technically don't need either of those things to go live in production, but if you forget about one of those things, you're probably going to be in a world of hurt down the road. And so no design for logging. If you don't think about logging for every single project that you're implementing, you're again, it's going to be a short-sighted approach. And then lack of standards. I've seen this quite a bit where developer A might be logging in JSON format. Developer B might be logging in key value pairs. Developer C might be logging in just plain text and hard coding everything. And then you mash all those up together and they all get pumped into something like Splunk, and you're trying to search for what happened in a request. And now you have all these different log formats come up and the system becomes less supportable, right? So lack of standards is a big common pitfall that I've seen especially across developers. Hard coding is another one. So I think there's times to hard code. You probably want to hard code messages throughout your system so you can tell at what point in the system you're at. But hard coding things like errors, for example. If you hard code an error, let's just play out that scenario. If you hard code an error, what's going to happen is your hard coded message will be logged every time, and the actual error itself might get lost, right? So you want to, where possible, log dynamic error messages, and dynamic error messages meaning, what is the error that occurred, for example, sort of variabilize your error messages, or messages where it might make sense to variabilize. And lack of request identifiers is also a really, really big one, especially now in this world of mini microservices. If you don't have a request identifier, you're not going to be able to tie one execution of a Lambda to the next. And so you need that request identifier to be able to tie those together. And next one would be logging payloads or sensitive data. And this one is really, really common, actually, where you log sensitive data. Maybe you're just logging an entire object that contains a password, and then you don't realize that that's actually getting logged. Then you need to go back and scrub that data. It can become a pain. See that quite a bit. And then you can log too much. Also, let's just say you're logging to a file system, for example, if you're running on an EC2. That file system obviously can get filled up if you're logging too much too fast. And so you want to look at, because the next one is logging too little, right? So you want to look at logging just the right amount if possible. It's kind of the right balance between logging too little and logging too much. It's just the right amount of information to be able to trace requests across your system. And so I wanted to look at this logging common pitfalls example, and I'm curious, again, if anyone can note the common mistake that happened in the top picture here. Does anyone want to come off mute or put it in the chat? What common mistake would be happening in this top picture?
2 timestamps.
That's a good one. Anything else?
127001.
I actually didn't notice the 2 timestamps. That's a good one, yeah.
And 127001.
Yep, absolutely. And the other one I noticed is, I think it seems okay at first if you're looking at, okay, I got some 200s, I had posts, coming in at these times, but then looking at it, also, you have no idea what request was made besides the metadata of, 200 or a 404 and a post and the timestamp. Like I think, David, that was you saying, all you really have here is the IP address, which is the local host. You're even masking the IP address. You have really no idea where these requests are coming from, or if you get a 404, for example, what's going wrong. You probably want to be able to log exactly what's happening, especially in the cases of errors. So if you were to come into the system and look at this, somebody's telling you that they're getting a 404, but there's 5 clients telling you that, you're going to probably have to make an educated guess as to which 404 you're looking at here in this particular picture. So here's the answer, kind of floating out on the screen. There's no identifier on these logs here, and there's not proper metadata logged for this top picture. And then obviously for the second one, that's bolded in red, where we're logging sensitive information. Again, see this all the time, logging that username and password. If you're just logging that CMD object, it's very, very common. But let's dive into best practices. So again, changing the background. This is where we would want to take notes if you are taking notes. And the number one best practice is identify standards. Standards really will catapult you into having a successful logging implementation. And whether your standards are JSON, whether your standards are key value pairs or other formats, it doesn't really matter. As long as you have standards, it's going to be better than an implementation without standards. And I would recommend, go with JSON. So many different target logging systems speak JSON these days, including AWS CloudWatch Insights, for example, that you probably want to log in JSON, and it's fairly human readable. Systems speak it. Many developers speak it. It's a really good format to be able to log in these days. Number two is informative messages. And it's sort of the antithesis of what I said for the common pitfalls and not logging enough and not having the proper visibility. So informative messages would mean that you're logging the type of messages that allow you to get the visibility and traceability throughout your system and see what steps occurred in your system. And log that request identifier. Whether it's a 36-character GUID that you're creating manually, whether maybe a client sends it with their request, a unique identifier, log that request identifier across microservices especially. And then dynamic error messages, I think I've already drilled this one home. Dynamic error messages is really, really important. I've been on the receiving end of supporting a system where we're just logging hard-coded error messages, and you ask yourself, okay, what was the error? And the error doesn't actually get logged. And then you have to go back and change that. And it's, again, just doesn't make for a good supportable system. Persisting logs to an easily accessible system. So for me personally, I would highly, highly recommend pumping your logs into an external target system, something like Elk or Splunk or, CloudWatch these days is pretty accessible. Persisting those logs into something accessible for support staff especially is becoming very important. And then logging at appropriate levels. So, use those info logs, use those debug logs, use the error logs. It becomes nice to be able to search for and support. And then logging the appropriate amount of data. So again, not too much, not too little. And really the message here, if you're gonna go home with anything from my point of view, is standards is absolutely key here. And standards unlock potential. And they unlock the ability to stabilize a system if you know what's going wrong with the system. And also, they would then allow you to, once you're stable, they would allow you to optimize your system and to know exactly what's occurring in your system. And those are really the key benefits now if you have a good logging foundation. And feel free to put in the chat, by the way, if there's any common pitfalls or best practices that I might have missed, I would love to hear those. Moving on. Logging best practices example. You can see here, I think this is a good example on the left. You get number one, just some metadata about the process. It's just an event time. It's a very, very basic example. You get that request ID. You can see this 1, 2, 3, 4, 5, 6 request ID is across all three of these messages. And it's logged in JSON in a nice standard format. And then the actual message itself allows us to see step A, B, and C of what occurred for this particular request. So I accepted a request, the system processed the request, and the system sent an HTTP request successfully. You know exactly what occurred in there. And this would be the exact same. I'm showing a screenshot sort of on the bottom right of Elk there. If you search for this 4D9 ID, what you can do is when you search for that 4D9 ID in Elk, is you can see all of the instances of that particular request identifier come up, and you can trace it throughout its life cycle again. So just a quick example. Another quiz question. This will be the last one. I'm curious if anyone can name 5 commonly used logging levels. You might even think sort of in terms of Java here, or if anyone's used log4j2. Again, feel free to come off mute or put it in the chat. Can anyone name 5 logging levels? Info, debug, error, warning, trace. Yeah, awesome. That's what I had. So if you didn't hear that, that was quick. I had trace, which would be the absolute lowest level, debug, in order, info, warn, and error. Nice job.
You beat me to it even. And I wasn't even typing.
All right. So let's talk about more of what we're specifically here to talk about today, which is AWS and that serverless logging. And I like to line these up against each other because I think if we're looking at traditional application logging, and just to define that, I think of that as sort of a legacy application, or maybe something running on EC2, or essentially it would be a monolith, right? It's not using a bunch of distributed microservices. When you line these two up against each other in traditional application logging, you see that it's single application focused. You see that logs are coming from that single source, wherever that single source might be. There's very predictable logs, which is very nice on the developer and the people supporting these. It's nice and predictable. There's a nice assembly line of logs, so you can ship those logs out to a target system, or the last line item here is they're typically written to a file or even the console. But it becomes very easy to be able to ship those out like a nice assembly line, because it's just one stream of logs coming out of a traditional application. Then if you look at serverless logging, now we get complex and messy. So serverless logging, I put multi-microservices focus. So it's mini microservices. I don't think I've ever seen a serverless implementation with just one Lambda. And I think most people would agree here. And so these logs are coming from many distributed microservices because of that. And there's an unpredictable nature about these multi-microservices approach. It's very unpredictable. Anyone can be invoked maybe at any time, or if you're chaining them together, you're always going to have many Lambdas invoked for one particular request. And really that can make it a spaghetti mess of logs. Something can execute before something else. You might have out of order logging, and so these are the things that you need to think about. And it's typically written to a centralized logging tool/system, and that's what I would highly recommend, because it gets so complex with the constant stream of logs across microservices that if you don't consolidate them, it can become a huge mess and very hard to support. And so the traditional logging architecture is very clean and simple, might look a little bit something like this. It's very straightforward to implement a logging approach in this sort of environment, where maybe you have clients making requests to an API. That API lives within an EC2, and maybe within that EC2, there's also a processing layer. So your API can communicate with that processing layer. Maybe it's even a front-end application, whatever scenario you want to dream up here. But essentially, you just have one EC2 producing logs, and you can ship those logs out to something like Amazon's Elasticsearch service, or Splunk, or out, wherever you want to ship those logs. It's a nice assembly line of logs being produced and being shipped out to a target system. And now to compare that to serverless logging, now it becomes very messy. You see all of these lines running into Amazon CloudWatch, and serverless logging gets messy and can be hard to maintain those best practices that I just talked about if you're really not careful in setting good standards. And so what you might see here is that somebody is making requests to many API gateways. And behind those API gateways, you might have many series of Lambdas. You might have, in this case, there's almost 10 Lambdas on the screen here. And all of those Lambdas, of course, by default, they're pumping their logs out to Amazon CloudWatch. And from CloudWatch, you might be pumping those logs out to, again, Amazon's Elasticsearch service. But you can see here now that if you're not creating great standards across all of these microservices, well, you might be in a world of hurt once those logs get into Amazon's Elasticsearch service. Yeah, David, was that a question? Did you want to say anything?
Oh, I am so sorry. I didn't realize I wasn't on mute. I just sneezed.
Oh, no problem. No problem. So real quick before we talk about kind of the end game here in Jerry's demo, is serverless logging pain points. So number one pain point in looking at that diagram that I just showed is many distributed microservices that communicate with each other, or maybe they don't even communicate with each other. But what you have to do is if you create a standard of logging across your microservices, now you might be running into code replication, for example. You might be replicating, producing logs from each one of those microservices into each one of your Lambdas. And so recommendation from me would be to add a logging framework as dependency. So you're minimizing that replication across those Lambdas. And otherwise, really what you can get, again, is the same implementation of a logging producer in each one of those Lambdas. And another logging pain point that you can run into with serverless is log scaling. And the amount of data coming out of these microservices these days is pretty astronomical. And if you're not careful of the amount of data that's coming out of the microservices, you're going to have to look at what target system that you're logging to and make sure that that target system can scale with the amount of data that you're producing, or scale back the amount of logs potentially that you're producing or shipping off to that target system. And number three, the default target for AWS Lambda is CloudWatch. And I listed this as a pain point. It's not necessarily, that in itself is not necessarily a pain point. I think CloudWatch is great for console logs. It's great even for debug or potentially even trace type of logs. It's good for a console type of logging solution. But in my opinion, it's not so great for many different microservices and searching. And I say that because if you're not familiar with Lambdas produce a different log when essentially they go to sleep and then wake back up. And then also across Lambdas, you have a different logging group as well. And so Lambdas themselves can produce different logging streams. So you might have to search across different logging streams, and then different Lambdas have these different logging groups. So it's a totally new group that you might be searching in across different Lambda executions. And I think CloudWatch Insight really helps to bridge the gap here. But CloudWatch Insight, I think you need to first be able to set up many great reusable queries, number one, in CloudWatch Insight. And number two, CloudWatch Insight, I don't think is necessarily ready for prime time. I think the tools like Splunk and Elk and those types of tools that provide, essentially a NoSQL database out of the box are much easier on the user to be able to access and execute queries very easily. And I'd love to hear any differing opinions, by the way. But that's why I say that Lambda logging to CloudWatch is a pain point. And then minimal logging frameworks that work well for serverless implementation. So if you're familiar with Lambda, you need to be able to close out all of your threads before a Lambda actually completes. And that's especially pertinent with Node.js, if you're familiar with Node.js. And if let's just say you're logging out to a logging target like Splunk, and your Lambda, what can actually happen is your Lambda can complete before that actual request is complete. And what will happen is you might drop a log at that point. So what you want to be able to do is finish out all of those threads where you're logging out to whatever target you're logging to before the actual Lambda completes. And we did some research and found some logging frameworks that try to accomplish this. But in terms of the service logging and for Lambda specifically, we couldn't find any that actually make sure to close out all those threads before a Lambda finishes its execution. So that is a pain point that we've run into, at least. And then service logging must-haves. So the best practices that I listed before, again, I think are only amplified with serverless. And you need to take time with your serverless implementations to properly log from each AWS Lambda and put extra focus on the design and implementation of that logging. So number one would be a centralized logging target. I think that's so important because you have many distributed microservices, as I've said. The reference ID to reference across microservices, again, is so important because if you have one API request, but behind that API you have 4 different Lambdas, you need to be able to tie all of those Lambda executions together. And so you need some sort of reference ID to be able to do that. And then logging the execution ID, I found it makes your system much more supportable as well. That execution ID can really come in handy for things like duplicates. For example, let's just say SQS produces a duplicate message. You might log that SQS ID, or your Lambda produces a duplicate. And that Lambda now, that AWS execution ID, you can see is the same across executions. It's good for the lower level supportability type tasks. And then metadata about the process. And what this means is that, again, if you have 4 Lambdas that are chained together, you need to be logging some good metadata across those Lambdas about what process you're executing. So maybe it's something along the lines of you have an interface ID, for example. That's very common in the integrations world. And you're logging that interface ID and what source and target system you're integrating with as metadata about the process. And there's so many different options with serverless logging. And I'm not going to necessarily dig into all of these. CloudWatch has been mentioned, Splunk has been mentioned. I've worked with Loggly and Elk as well, and Graylog is up and coming. I've even seen clients log to a database. If you just want to be able to allow your users to execute SQL queries on a database, more power to you. Sometimes that's the right solution. X-Ray is a decent solution. I would say that's more for detecting where there's latency gaps in your Lambda executions, though. But there's plenty of options out there in the marketplace, and I'm not necessarily recommending one option here. I'm kind of just saying that there's many out there, and you should log to at least one. I think there's pros and cons to many of these approaches. So traditional logging versus serverless logging. And a modern environment might have, an iPaaS implementation combined with a serverless implementation. It might be a hybrid environment. So how do you actually bridge the gap between a hybrid environment, 100% serverless environment, or just something sitting on an EC2? A legacy system might also be combined with AWS to extend that legacy system. An EC2 might be combined with a serverless implementation. I think there's an infinite number of combinations. And I think it's also rare, unless we're just talking about, maybe a lightweight application built 100% in serverless, that an actual system is really 100% serverless. I think that's rare, at least in the integration world. So a modern environment might look something like this. And this slide is packed now, and it gets even more messy, right? Even more messy than that serverless architecture that I showed a few slides ago. So you might have an 80% serverless implementation here, but towards the bottom, you might also have an EC2 in the mix, and you might have an iPaaS like MuleSoft. And you need to be able to log from all of these different systems in the same way to be able to centralize and consolidate these logs. It's a really, really common use case, and that can get really complicated. It's not trivial to be able to accomplish that. So I think you need to think about a few things. You need to think about the producing side and replicating the production of these logs from all of your different Lambdas, your EC2, your MuleSoft applications. And you need to be able to produce these logs from all those applications so that it can be centralized in that target system that you want to pump them into. And you also need to think about, along the way, how are you doing that in a guaranteed manner, right? And so now that's on the consuming side. That's another thing that you need to think about. And maybe on the consuming side, if you're pumping these logs into, let's just say, Amazon Elasticsearch service, you might ask yourself, do I need to scale or throttle? Do I need to guarantee delivery? Or is it okay that I might lose one of these logs because I have CloudWatch as a backup, for example? Or you might even need to ask yourself, do I need to pump these logs into multiple destinations? I've seen that with a few clients. And sometimes you do need to do that. Maybe you need to pump them into a database for business intelligence purposes. And then maybe you also need to pump them into a very transactional store for very low latency type of requests. And so what we set out to do for the demo that we're going to show and for our projects is to create a framework that can be used for serverless and for legacy systems and for iPaaS and for applications living on EC2, because I think the modern environment is a hybrid one that combines all of those. And we personally use all of those, not just serverless. So we created a logging framework that can be used for really, we're calling it internal and external applications. And what you're going to see here is there's kind of two portions of this, as I mentioned. There's a producer portion and a consumer portion. And the producer portion doesn't care about the consumer side. It's completely decoupled from the consumer side. And it's just a dependency in the producing application. So, in your AWS Lambdas, you can add this dependency. Or, if your application is legacy and it struggles to add dependencies, you can just make API requests to this API gateway that we have as an inbound endpoint on the screen. And really, the producer allows you to send logs to any number of arbitrary targets, as we'll see in the demo from Jerry here in just a minute. And the consumer portion doesn't care about the producer side. It's completely decoupled from the producer side. And remember, this is just one consumer that we're showing here on the screen. There could be any different number of consumers. And it's a reusable consumer for the purposes that we had talked about for a use case that we're going through. And so we used, in this case, Elk. And it's actually Elk installed on EC2. So this diagram is off by just a little bit. But what you also might do is use AWS Lambda to pump those logs behind SQS into Amazon's Elasticsearch service. But what we really have sitting behind the scenes here is an Elk implementation on EC2, just picking up messages from an AWS SQS queue. And so that guarantees the delivery of these messages into our Elk instance. And it also allows us to scale and throttle that particular solution. So what you'll notice with this is that there's many different producers and only one consumer. But that consumer has two different inbound endpoints. The first inbound endpoint is API gateway. So if we want to make this available to, for example, external applications, anything sort of outside of our internal circle that we don't want to give the keys to the kingdom to, we can just say, hey, make a request to this API in this particular format. We have it defined in Open API spec, and we're going to pump that log into Elk. But what you can also do is maybe as an internal application, and you do have a client ID and secret, a secret key and an access key and a secret key, you can send these messages off to SQS, because SQS simply sits behind that API gateway and everything lands in SQS anyway. And you can send those messages directly to SQS to then, again, get pumped into Elk. And so that's the thesis, that's the genesis of what we had delivered on as a logging framework to combine this serverless architecture mixed with sort of an always-on architecture like an EC2 or a MuleSoft. And I think this is the modern type of environment. And I would love to hear what everyone thinks. But I'm going to, at this point, let Jerry present. I'm going to stop sharing my screen, and then we can take questions at the end.
Okay, hi guys. I'm going to turn the video on just for a sec to introduce myself. My name is Jerry. I'm one of the senior consultants at Big Compass, and I'm going to be showing you a quick demo that reflects the architecture Aaron just showed us. So with that, real quick, I'm sharing my screen. And just so you can have more screen to see, I'm going to go ahead and turn my camera back off. 1 second. There we go. All right, so I'll be showing a demo that reflects this logging architecture. And to start off, I'm actually going to go backwards. So I'll be showing the right side of this architecture first, the consumer side of the logging framework, and then I'll be showing the producer side. So first off, I'll be showing how we set up this API gateway to SQS, and instead of AWS Lambda and Amazon Elasticsearch, in this demo, we're going to be using just an Elk Stack instance that's running on a small EC2, just for our demo purposes. But it works very similar to this architecture. So we set up this right side of this architecture using CloudFormation. And for those of you that don't know what CloudFormation is, taken straight from the docs, AWS CloudFormation provides a common language for you to model and provision AWS and third-party resources in your cloud environment. So in layman's terms, CloudFormation lets you configure a template and feed that template into the CloudFormation service, and it will provision resources for you based on that template. So in our CloudFormation stack, we're specifying 13 resources here. The three that are most important are the API gateway, which is right here, the log queue, which is the SQS that's in the architecture that we were looking at, and an EC2 instance. And this EC2 instance holds an elk stack that will be sending our logs to. So just remember, so there's 13 resources here. A lot of them have to do with identity access management, so roles and other things that help coordinate communicating between the SQS, the API gateway, and the EC2. But basically, all you really need to know is that this CloudFormation template that we've made basically provisions all of the resources here, and it provisions the communication between these resources as well. So real quick, one last thing I want to show you about CloudFormation is the template itself. Now, I'm not going to go into every specific detail about this template. Some of this might look crazy if you've never worked with CloudFormation before, but with a little bit of practice, it actually would probably make sense. So for those of you that are seasoned in CloudFormation templates, you probably understand what this looks like. One thing I'm going to show is just those three key resources, though. So first off, we have our API gateway specified right here. And this API gateway is configured to simply proxy messages and pipe messages into this SQS queue that we have specified here. And the most important piece probably is the EC2 instance that houses our elk stack. We run a lot of configuration when the EC2 is initially set up to basically provision an elk stack onto it. And then one of the most important pieces in that part is we create this file, logstash.conf, that actually references the SQS instance that we're provisioning in this CloudFormation template. So how it references logqueue.queuename, it's specifying that SQS as an input to our elk stack instance. So what's neat is we were able to set up this entire right side of this architecture all with one template file, and basically very quickly get up and running with an SQS to API gateway to elk stack type of flow to completely create our central logging system. So that ties into the best practice of, or the must-have of having a centralized logging target. That entire CloudFormation template basically creates that for us. And if this isn't necessarily a production-ready CloudFormation template. It uses just one small EC2 instance, whereas probably in a real implementation, you might need an EC2 fleet, like multiple EC2s and bigger EC2s. But we would be willing to let anyone that wants this template just have it for experimentation for their own purposes. If they would want to play around with it, we would be happy to pass it off to anybody that wants it. So like I said, this is the consumer side of our architecture. And at this point, you already have a lot going for you. As Aaron said, you already have a nice API endpoint that you can simply pass log messages off to. And that's a great starting point just from the get-go. Instead of having all of your Lambdas log to their own CloudWatch log groups and have a giant mess, you could at least have them making calls to a single API endpoint, and at least they're all going to one location. However, obviously there's many more best practices Aaron highlighted here, such as having standards, informative messages, request identifiers, and things like that. And Aaron mentioned a logging framework, and we're going to show that to you now. As he said, we looked into multiple logging frameworks, and just to clarify, we are doing this demo in Node.js. So when Aaron mentioned that the logging libraries out there don't really work well for serverless, we're talking specifically about the Node.js world. So we looked at many libraries like Pinot and Winston and Log4j.s and Morgan, and we found that they all had that one specific problem that Aaron mentioned, which was that you couldn't wait for asynchronous requests to external services before exiting your Lambda. So I'll show what we mean by that here in a second. But this is our own logger library that we made to help us out with standardization and with logging the most important data that we need, and with logging request ID and execution ID and all of the things that Aaron laid out in the best practices. So this is Logger, a clean, crisp brew of a logging library that even tastes good on serverless architectures. I'm not going to dive too deep into the entire README of this library, but just to show how the standard usage works. If you've ever worked with a library like Winston, you would probably feel at home with this library as well, because Winston inspired a lot of the design of this library. The basic idea is that you use Logger to create your own logger, as you can see here, and you can specify default properties for your logger, and you can also specify transports, which basically consist of the destinations you want your logs to go to and the log levels that you want them to be sent at. So for example, this transport represents logs will go to the console for info level and above, and error level logs will go to this HTTP endpoint. Error and critical level logs would go to there. So that's the standard usage. It's kind of how it works. And I'll be showing more in our specific demo of how to use this in action. But basically you have a bunch of log levels and you can just call them as functions here. So you have logger.debug, logger.info, logger.warn. You can pass objects into it. So that fulfills the best practice of being able to have informative messages, because you can pass as much details into these logs as you want. And you also have standardization in these logs. By default, this library uses the JSON format. And as Aaron mentioned, that's a pretty great format to use for most systems. We do plan on adding more formats to this library later, but so far we only have it just using JSON format. But as you can see here, for example, this warn log that has this string message here, and it has some object in it, it results in this message represented above here as JSON. So it tacks on the level, the string that's sent in, it's placed in this message property in the object, and some default properties are added to it, and then finally your warning property. So that's basic usage of this library. And then I'm gonna also just real quick show, this is basically why we had to make this for serverless, as Aaron was talking about, was you need to, when you're logging to external destinations, you need to make sure that your Lambda waits for all of the requests to external log destinations to finish before exiting your Lambda. And it was actually very surprising, because we tried very hard to get this working in other logging systems in Node.js, and we just couldn't find a great way to do it in some of the popular ones. So we ended up making this one to do this for us. Simply at the end of a Lambda, you can call logger.flush as we do here, and that basically just makes sure that all of the external HTTP requests are waited for before exiting the Lambda. And by the way, if anyone does have experience working with other popular Node.js systems where they were able to pull this off in a serverless environment, we would be very happy to know how to do that. Like for example, doing this with Winston or Pinot or something like that, because we actually tried pretty hard to figure that out and ended up having to resort to making our own library to do it. There's a lot more in this README here, but I'm going to just show how this library works in action in our demo. So for this demo, we're going to be logging to the elk stack instance that that's represented by the right side of our architecture here. And we're going to be doing it from a few lambdas on the left side. So it's not going to have an EC2 instance or a MuleSoft, but we'll have 3 lambdas that are actually calling each other and are logging to the same elk stack instance. So I'm going to switch over to the project just to show a brief overview of it.
Jerry?
Yeah.
Sorry, I have a brief question. So on the slide or one of your previous, you talked about this asynchronous, you have to wait for this call to come back, right? In the catch block. I was wondering, why is that even needed? Because the moment you say log.info or log.error, you collected all the information and you sent the package to the logging system. That should do it, right? Why do you want to wait for that request to complete?
We've actually noticed before when sending logs out to HTTP endpoints and using SQS's SDK, like AWS's SQS SDK, we've noticed logs actually dropping off due to our Lambda exiting before they finish they finish the request. So we resorted to doing this at the end. We've had this. We've experienced this at a previous client before, and we've experienced this in our own experimentation as well.
Right. Okay.
Yeah, essentially we're waiting for, we're ensuring that all those promises resolve.
Right. My point is, it's a HTTP, it's across internet. So it's a fire and forget type of deal, right? You construct the package, you send it to the internet, that is it. I mean.
Yeah, the problem is actually in between. So if we spin up a thread to log to a target, let's just say it's an API gateway, and the thread never even executes before the Lambda finishes, that's where we get the dropped logs.
Okay.
So it's actually before, even sending off that HTTP request, right?
Right. So before that, if your code is execution is done, then you have a problem. Yes.
Exactly.
Yeah, yes, exactly. Thanks, Aaron. Okay, so unless anyone has any further questions about the library itself, I can move on. I'll move on to the demo itself. So we're going to be logging to that elk stack instance, and this is actually our dashboard for it. There's no data in here right now because we're not actually sending data to it just yet. So when I say sending data to it, the only data going to this is going to be data from our logs. So this is the demo project that will be sending data to that elk stack instance. And it looks a little complicated, possibly. This is actually just a serverless framework project. For those of you that don't know what serverless framework is, it's a separate framework that's very similar to CloudFormation, but it's not affiliated directly with AWS or anything. But it's a nice framework to use for setting up purely serverless architectures. So this demo project just uses that. All it consists of is 3 lambdas, and this project is called Who's That Pokemon? So there's a catch Pokemon lambda, a fetch Pokemon data lambda, and a process Pokemon data lambda. And basically, catch Pokemon sends data to fetch Pokemon data, and that sends data to process Pokemon data. These functions don't actually do much. It's just for the intention of logging a bunch of stuff from these. And they actually all randomly error out just for the purposes of showing how this looks when you send errors to the elk stack instance, and how you can debug errors in elk stack. So each one of these functions here has a little mock error function inside of it, where it'll error maybe 15% of the time, 25% of the time. You get the point. Real quick, before I actually run a simulation that will pass data into this system, I'm going to show the logger itself that we're using. So this logger instance will log to the console log, as we can see here, at the debug level and above. So like Aaron said, it can be really nice in AWS Lambda to log debug level type of logs to CloudWatch, whereas you wouldn't necessarily want to log everything to your centralized log location, which in our case, we're only logging info level and above to our centralized log location. And we're actually going to be logging directly to the SQS instead of using the API endpoint, although we could be using the API endpoint that we stood up on the right side of our architecture diagram. But since this is an AWS Lambda that has direct access to SQS, we decided to just log directly to the SQS queue. This has some default properties in it. This is an example of adding a static property. This just tacks on the project name. Our logging library lets you specify some computed properties. So we're actually adding some dynamic computed properties, such as the timestamp. And these two are actually special formatter type of computed properties that you can do with this logging library. Our computed properties are interesting because they have direct access to the log object itself. So in these, I don't want to dive too deep into this, but just suffice it to say that these two are how you would do formatters in a log in the logging library. In our case, we're changing some Boolean values to 1 and 0 because it helps to make nice graphs in elk stack if you can have numeric values for certain things instead of true and false. So just real quick before I run this simulation, I'm going to jump over here and show what we're actually logging. In the catch Pokemon function, we're just logging some info data, logging lots of debug data that you won't see in the elk stack instance. And each one of these are, I want to point out, they set their own default properties as well, which you can do after creating your logger. So after you create your logger with this logging library, we made it so you can add default properties to it as you go for whatever use case you have. In our case, it's very common to maybe pull in your logging library that you created and then add new default properties to it, such as your request ID, which is our AWS request ID. And we're specifying this job ID here. And so in our case, the job ID maps to our job ID maps to the reference ID that Aaron mentions in this slide here. So the job ID is the reference ID that references across all of our lambdas, and then our request ID represents the execution ID to reference each individual lambda execution. So we're doing this in each of our lambdas, and what you'll be able to see, we're basically going to show you how useful this is for debugging specific errors. So all of these lambdas are kind of logging in the same way. They're also logging errors. This logging library can take in just raw JavaScript errors and formats them nicely by parsing out the name and the message and the stack trace and sending that in with your log and the log object. And you'll be able to see how that works too in a second. So unless there's any questions about this specific project, I'm going to go ahead and just start running a small script that'll simulate some data. So this is just sending this is just sending 4 to 6 Pokemon into our system. And that system is logging some data about the Pokemon and logging errors and things like that. All the errors that we'll see in the ElkStack instance will most likely be those mocked errors that I was showing you. And so I'll switch over to the ElkStack and refresh our data. We should see data coming in. So we can already see the usefulness of this. This is the visibility side of things that Aaron was talking about when he was talking about visibility and traceability. A support person, for instance, could get right onto this page and see, oh my gosh, we have 39 errors and only 4 successful requests. You know, that's the quick visibility that you can have if you take the time to set up this kind of logging framework. We only have 5 graphs in here, but really, depending on your data and your use case, you could have over a dozen graphs or maybe even more, depending on how much data you're working with. So this is the visibility side of our ElkStack instance, but also obviously we need to focus on traceability as well when we're logging. And traceability is most important when you're having, you know, a ton of errors going on in your logs. So I'm going to just run through and show how we could actually look up an error that's happening. So this is an error table. We see that we have 21 errors of a big problem happened in our process Pokemon data function. So I'm actually going to just grab this error message. In an ElkStack, you can easily trace messages or trace problems by going to the Discover page. I'm actually going to just look up this message first. A big problem happened, and so we can see all the individual lambdas that threw this message in the last 5 minutes. And what's really nice is, since we're logging that job ID, that basically glues all of the lambdas together. Well, for one thing, we can see the full error stack trace. But then, since we log the job ID that basically glues all the lambdas together, we can take that and just put it in here. And now we'll be able to see an entire job from start to finish and how this error was reached. So we see here, we're starting the catch Pokemon job. It sent it to the next step, started the fetch Pokemon data job, that's successfully completed. And then finally we got to the process Pokemon data job and hit the error. Obviously this is a fake error, so it's not as useful, but in a real world scenario, this can sometimes be way easier than digging through your traditional server environments, file logs, and trying to figure out where the beginning of a problem started. This is just a nice overview, and yeah, it honestly, it makes it so you just look up what's happening in your project and figure out specific problems really quickly, and it takes away all of that hassle. So I hope this kind of sheds some light on how we can achieve these best practices in a real world scenario. And with that, unless there's any questions, I'm going to go ahead and pass it back to Aaron. Are there any questions about the demo itself?
Yeah, I had one question. Is there, you mentioned the problem with lambdas, and specifically, did you guys try that parameter that's on the context object that you can basically flip that immediate killing of the handler off for that particular execution? I don't remember the exact parameter. I'll look it up real quick. But there's an option on there that usually when you have those sort of async problems where the handler will exit before your async call is done, there's a context variable you can flip.
Right.
Honestly, I did not know that.
I've done that before, and if I'm remembering correctly, it was Matthew, right? The
Yeah.
downside of doing that is you eliminate the sharing of objects across Lambda executions. Is that, do you know if I'm remembering that right? It's been a while since I've looked into that.
Oh, I wasn't aware of it, but what kind of sharing are you thinking?
So when you instantiate objects outside of the Lambda handler,
Right.
those can be shared, you know, intelligently. AWS handles that, but those can be shared across the Lambda executions and helps with things like cold starts and, you know, just efficiency of your overall Lambda.
I wasn't aware of that changing any of that. I mean, yeah, but I think it's generally best practice to try to keep everything in the handler, but sometimes you can't.
And yeah, those more global objects. So let's say it's like a database connection.
Right.
Yeah, you know, you can instantiate those outside of the handler, and it'll increase efficiency if you do so. I would be curious to try that though, Jerry. I hadn't actually thought of that, and it'd be something it'd be cool to try. And I'd love that you can get back to this group on. I remember there were some downsides to it, Matthew. And I think I'm remembering correctly. So maybe the answer is it might depend on your use case. You know, if you need to share those assets across Lambda executions, then
Yeah, sure.
you know, maybe not. But if you don't, yeah, you know, it probably would work.
And is
Default, it has debug and pretty easy to just replace the console functions for the most part. Might work a little differently if you're getting really fancy with your console functions. I'm not completely sure, but it should be pretty easy for the most part.
Cool. I tried looking this up. Is this not public yet?
Yeah, I forgot to mention that. We haven't made it public just yet, as we're kind of wanting to make sure we have full test coverage and fleshing out a few more features and things like that. But we do plan on getting this published to NPM probably by the end of the year. And that's kind of a conservative estimate. So yeah, hopefully should be up at NPM by then, and it's probably going to be under, there's already a library called Logger, but it's very small, not supported, that kind of thing. So we're probably going to call it, you know, at BigCompass/Logger. Yeah. So with that, I'm going to go ahead and stop sharing. And Aaron, I'll pass it back to you.
Yeah, and I was just furiously Googling. We're essentially done here. I'm going to share my screen again in a second. But Matthew, that callback waits for empty event loop is the property. I'm not going to research that after this and refresh my memory on that one.
Well, and it may not be good to depend on that, because that could have some really nasty side effects with existing code bases.
It could. And that's what I'm sort of remembering is there were downfalls, but you know, hey, maybe it works in certain use cases. So let me share my screen again. Okay. So that was the demo. Thank you, Jerry. Next steps, essentially just as Jerry had mentioned, I would love it if anyone were to use this framework. You know, we're not trying to pitch a framework here. We're not trying to sell anything. We seriously recognized a pain point and sort of created this framework that we will use internally. I would love it if anyone externally, you know, forks the repository, clones the repository, uses it, lets us know how it goes. We can blast out to this group, you know, when that's published publicly. And again, that should happen by the end of the year pretty easily for us. So would love it if you guys use it and provide feedback, and maybe you even create some features, you know, you fork it and make it even better. that would be awesome. It would help us and help this community. So those will be next steps. And at this point, I'll take questions, and I'll just say, you know, Jerry and I are open books. Feel free to reach out to us, connect with us on LinkedIn. Feel free to email us. My email again is aaron@bigcompass.com, and looking forward to, you know, just staying connected with this group. I'm liking the involvement with this group. So, any other questions for us?
Just one basic question. You might have an answer right away. So if you you have multiple logging statements close to each other, each log statements make a HTTP call, right? And there's no guarantee of maintaining that order because the second HTTP request could reach the server first, and your messages could get swapped in the server.
And on top of that, you'll have an SQS queue that we didn't even use a FIFO queue here. And so those messages could even get out of order. And hopefully I didn't cut you off there, but you know, we like that we're pumping these logs into a system that won't necessarily care about order, because we can index those and, you know, search based on that timestamp and order them based on the timestamp. In our scenario, at least. Did I cut you off there, or was there another part to that question?
No. So when you showed the Kibana UI, you know, you search for a job ID, right? I mean, you can really see it's like, okay, begin some task and end some task. So a end task could appear before the begin task, right?
Absolutely.
Yeah. So in Kibana, what you can do when you're setting up your index, it'll let you set up your index based on a timestamp. So when we set ours up, we actually based it off of the custom timestamp that we send in with each log message. And so that basically guarantees order in the Kibana dashboard itself, if that answers your question.
Yeah, so it's basically relying on the source timestamp when it got
exactly. Exactly. I would relate it back to the metadata of the process. Like, one thing we've always done in our implementations for logging is we always generate a timestamp to ship with that log.
Right. Okay.
No. Yeah. And then, you know, these tools are getting so good that you can index based on those timestamps, and you know, then you don't need to worry about ordering and FIFO queues and things like that.
It is a good question though, because you, by default in Kibana, for example, you can index based on Kibana's own generated timestamp. And that's something you generally in most systems would not want to ever do unless you're somehow guaranteeing delivery in order on the source side, if that makes sense. So that was actually something I ran into initially when I was playing with ElkStack for the first time, was that I used their system generated timestamp and all of my logs were out of order. So it's a very good question.
That's a great point. Yeah.
And is this something that we can use on the client side libraries at all? Like, for instance, I have a UI running on React or Angular. For a very critical issues, I would like to log on the server side. Is this the library that can help with that?
So do you mean logging from a client side system?
Yes.
We haven't actually tested it tons on the client side yet. However, it is just a plain old JavaScript library. I really don't see why it wouldn't work on the client side, but we haven't tested it tons yet.
Okay.
And one of the cool things Jerry and I talked about is, you know, today it's Elk, today it's Splunk, but tomorrow it's something else, you know, or, you know, Arun, in your situation, it's something very specific maybe that you need to pump your logs into. And you know, I think the great part of this framework is you can create these custom transports. So it's pretty easy to do. And we created like a baseline with the HTTP transport, which can go almost anywhere, right?
Yeah.
Yeah, and we also have for any scenarios where you have a destination you want to send your logs, but the predefined ones that we've made don't work for you, we also make it so you can just have your own custom function. I mean, for example, I think it would probably be possible to use this on the client side and like use Google Analytics SDK to send data out to Google Analytics using this library if you wanted to for some reason. Using custom functions as inside your transports. So it's kind of, it's very flexible, which was our intention.
Okay, thanks.
Like I said, we'll reach out when this becomes public. I'd love for you to try it out. And, feel free to get back to us with any negative or positive feedback. Anything else? Great questions.
Great presentation, you guys. Really well done. At least somebody came prepared. I'm going to go ahead and stop recording.